So what I did for the switching the directions of the wheels, the motor phase lines, there's three big fat wires for each motor, yellow, green, and purple. And what I did was I switched the yellow and green phases on the board underneath. So it's just some soldering, switching the wires. Now this motor controller has feedback from the motors to tell which direction it's spinning and how it's spinning. And so fortunately the boards were marked nicely, H1, H2, H3, and I noticed yesterday that there's the colored wires, green, yellow, purple, they happen to correspond with H1, 2, 3, not necessarily in that order. So what I did, I swapped green and yellow for the motor phase lines, and then also the sensor lines I swapped, as you can see with the heat shrink here, I swapped green and yellow, and I did that on both motors, and we seem to be good. I don't notice any issues when I purposely try and hold the wheel. The motor controller seems to be acting normally. Okay, so brain surgery on the juice boards. What we're doing, we're tying into the data line, so the clock and data lines here with very thin wire, to keep the two motor controllers or two brain boxes balanced, the battery packs balanced with each other. We're connecting to the battery line, but we're putting in a little polyfuse in there so that we're limiting the current that can flow between the two battery packs. And rather than drill holes in this thing, we're using the existing USB. Instead of carrying 5 volts for the USB, it'll carry battery voltage, 42 volts between the two boards, and then the USB data lines will be carrying the clock and data signals from the I2C. Okay, so here we have the two juiced power drive units. This is the original one. This is the rear side of the board. The brain boxes are still open. We're going to do the stitching to post-surgery to put the brain box covers back on and tidy up the wires. But what we've done is modified the USB connection to act as a data connection between the two drive units. Right now I've got a really long, it's a custom USB cable, but once the brain boxes and batteries are bolted down, I can shorten that up, and just showing you how things work. Turning on the rear wheel drive one until we see flashing green, and then I'll turn on the front one, flashing green, and there we go. So because the data from the receiver, the I2C data line is the identical data coming from here to this one, the motor controllers are seeing the exact data, so the wheels are going to spin at the same speeds. They're going to behave exactly at, as if it were a juice dual, but in this case, this is, I think, the first juiced quad that's in existence. And if you want to make it a single, you can simply turn off the power. That's the beautiful thing about juiced boards as opposed to boosted boards, is that there's no belts. So if I turn this front drive unit off, essentially it's a two-wheel drive skateboard, or if I don't want to turn it off, I can simply unplug this USB connection. This green light is no longer flashing, meaning that it's not receiving any speed control signal, but that's okay because these wheels can still do their thing. So that's what's so amazing about juiced. So what I've done is also with the rubber sealing gaskets, I've used that as a template as to where to put the holes. So I did have to drill 6 additional holes in the deck, but it's a really nice maple bamboo deck, so no problems there. So next section we'll have it all put together and we'll be trying it out. I'm not going to ride it myself because it will scare the crap out of me, but maybe David upstairs, who's more comfortable at high speeds.
Brakes work.
Yeah, I bet they do.
Yeah, you have to be gentle with the brakes.